Hello hires, we are now still on problem solving, data handling from the 2012 SQE pass paper. This is the revised hire at question 9. Right, so here's our context. Remind you, at any point you can pause this and then you can just read it through, make sure you know what's going on without necessarily listening to me talking it through. Okay, so what have we got? We've got human food production can be increased by the use of fertilizer because it improves crop growth. They have a field trial carried out to show how the mass of fertilizer applied per hectare affected the growth of a wheat crop and to determine the level of fertilizer which should be recommended. Fair enough, it's a totally reasonable thing to do. After the harvest of the wheat, at each fertilizer level, the following measurements were made. So we have total dry mass of the grain produced per hectare. And then they've got dry mass of a sample of 1,000 grains. So that's telling you basically how big each grain is getting. Okay. And dry mass, can't even remember if it's one of the questions, but we use dry because we're getting rid of the water weight, which is going to be variable for each one. Okay, so our graph in this one, not surprising, we now have a secondary axis here. So this is for this one and it's reading to this direction, and we have a dry mass of the 1,000 grains, and this is this line and it's reading in this direction. It's a reasonably nice divide. Okay, so here we're going up in, that would be 2.1 there, so we're going up in 0.05s. And over here, what's that going up in? That's going up in 0.2s. 0.4, 0.6, 0.8. Yeah, that's 26 there. Okay, that's all right. Okay, this is a description one, using values from the graph to describe the changes in the total dry mass of grain produced as the fertilizer application increased from 40 to 120. Now, this is the bog standard one in terms of you have to give all the points that you need to describe it, but what you have to recognise here is it says from 40. So you're only actually working from here. So all of this data, you're not even looking at. So you wouldn't lose marks if you gave the data, but if you gave the data, you'd have to give this point and you'd still have to give the 40. And let's face it, you wouldn't, because you would just give the 0 and then you give the next point up, which would be the 60. So that's how people are likely to lose the mark on this one. So you've got the 40, the 60, the 80, because you've got a steady that you're going to have to describe, and then you've got the 120. So you've got 4 data points for 2 marks. That's now, you should recognise as the common kind of thing. Occasionally it's 3, but if it's 3, it's been a tricky graph to read. So for this, you're going to have your 40 kilograms per hectare, and you're going to have to read off your data for that one. And this is, well, I've kind of scribbled over it, not making it that easy. There we go. 2.45 tons per hectare. Now, if you have not done that on the first one, you have a problem because you must give units. Okay, you've then got your 60 kilograms and your 80 kilograms and your 120. You need all those points. So we've got 60 is 3.6, 80 remaining the same till 80, and then we've got a drop, and the drop is taking us 1 over there, so 3.05. And I've seen people do all the hard work and like get this one right, get this one right, get this one right, and then when they get to this point here, because it's really close to this axis, they just would read it across and go, oh, it's 31 point, what did we say that was going up in? 2. And just lose the mark because of that. So just stay alert, keep paying attention. Okay, the average increase in total dry mass produced for every additional kilogram of fertilizer applied from 0 to 80. So we're still looking at dry mass, so we're still looking at this side. Here is our 0. Our 0 is 1.6. And here is our 80, which we've already read off at 3.6, because it's here. Checking this in line, yes, okay. So it's gone up from 1.6 to 3.6, so that is an increase of 2 tons. And that's from 0 to 80, so for 80 kilograms. So you just do 2 divided by 80. get my calculator out because it's been a long day. I know you don't realise that. Right, 0.025, and that's you. Okay, simplest whole number ratio of the dry mass of 1,000 grains produced at 0 to that of 120 kilograms per hectare. Okay, so this time we're reading this. So here's our 0 and here's our 120, but this time remember we're reading into this direction. So we have bang on the line there, so 27 going up to, I think that's bang on the line, let me just, yeah, must be because it's that one, it's going to be on this one, and going up to 33, so 27 to 33, let's cancel that down, so we're just going to divide them both by 3, so 9 to 11. Okay. The percentage increase, because that is much more common for you guys now than just a straight percentage, in the dry mass of 1,000 grains when the fertilizer level was increased from 20 to 80. So 20, here's our 20 point, and our 80, here's our 80 point. Remember, we're still reading to this direction, so trying to get my line across. I think it's this one. Well, that's okay. Is that right? Yes, so 28 is our start, and 35 is our end. For percentage increase, for any percentage change, doesn't matter if it's increase or decrease, it is the change divided by the start multiplied by 100. So our change here, we've gone from 28 to 35, so our change is 7, and our start was 28. So 7 divided by 28, actually can't believe I plugged that in, because that is 25%. Okay, at which fertilizer level is the average dry mass of an individual wheat grain the greatest? Well, this is the dry mass of 1,000 grains, but the largest of these will be the largest for individual grains. So there we go. There we go. That's it. Okay, D. Table below shows information about fertilizer levels and yields. Complete the table by. Right, now actually I left this in, but it's not actually part of the course content anymore for the exam. It is for the units but not for the exam. So insert the missing term to complete the column heading. For part 1, this is actually called the biological yield. Okay, but you don't need to know that. Insert the missing fertilizer level using information from the graph and calculate the missing harvest index. Now harvest index was in the course, but you can figure it out from the table, so I was leaving it in. Okay, so we know that we have total biomass, so that's going to be including water weight basically. Economic yield is the dry mass in tonnes per hectare, so we've got dry mass at 3, and this is tonnes per hectare, so I'm looking for 3. I realise this is very small, but if you read this across to this point and then read it down the way, you should get to this point, and that gives you 50. Okay, so this one here, the harvest index, well, you have to just figure out what it is. If this is 0.75 and you've got 3 and 4 here, the relationship there is, well, that's 3 divided by 4 because it's 3/4. So this one must be 3.6 divided by 4.5. So 3.6 divided by 4.5 gives you 0.8. And that's it. So don't worry about the first one, but you certainly can get these two. As a result of the field trial, the recommended level of fertilizer was 60 kilograms per hectare. If you remember right back at the beginning, it said that was one of the reasons for doing it. Suggest 2 reasons why this level was recommended. Okay, here is your 60. Now, basically, this is the smallest mass of fertilizer which is giving you the greatest yield. If you go up to 80, you're not getting any more of a yield from this. So the first point has got to be that this is the smallest amount of fertilizer which will give you the best boost. Okay, the second point has got to explain why you wouldn't say 80, and basically that's just pollution. That 60 to 80 is not increasing yield, so therefore it's just being used somewhere else. So there's your 2 things for that. Here's your SQE mark scheme. Make sure you're clear on what's going on with it, and that's another one down.